Hi, welcome to our debate. And today we are going to debate which would win in a fight. I'm Michael King, and I am debating for Apis cerana japonica, better known as the Japanese honeybee.
And I'm debater B, Lindsay Needler, and I'm debating the Vespa mandarinia, otherwise known as the Asian giant hornet.
For my opening statement about the honeybee, here we go. So, adult Japanese honeybees have branched hairs on their bodies to assist in pollen collection, while worker Japanese honeybees have a cubiculum on their hind legs to transport the pollen. The cubiculum is shaped like a basket, and it makes it much easier for the bees to collect all the pollen. The worker bees are the non-reproductive female bees. Workers build the hive and they keep it clean. They're also responsible for nurturing the larvae and pupae, and they also forage for the honey. The workers contain an ovipositor. This is typically for egg laying, but the Japanese honeybee has modified it into a stinger. The adults are also yellow and black in color. Japanese honeybees have 4 bands across their abdomen, which is one more than the European honeybee. And Japanese honeybees complete their development via complete metamorphosis. So they have an egg stage, larvae, pupae, and adult stages. Queens are the reproductive female in the colony. A Japanese honeybee colony may consist of 1 queen, many thousand workers, and many drones. Queens lay a single egg in each of the hives, and 8 brood cells the eggs hatch into larvae after 2 to 4 days. Some say they are originally from the current Korean peninsula and migrated to Japan.
Okay, so the Asian giant hornet, normally the eggs will hatch within a week and then undergo a 5-stage metamorphosis that takes 2 weeks until adulthood. The average size for an adult is between 2.7 and 4.5 centimeters. This excludes the queen, that's normally about 5.5 centimeters. And then the wingspan of the bees is normally about 7 centimeters, so they're really big. And unlike many normal species of bees and wasps, the stinger of the giant hornet isn't barbed so that it can be used multiple times, and it's known for its fearless and aggressive attitudes. The venom in the stinger is made up of 8 different chemicals, each serving a specific purpose, such as tissue deterioration, causing the sting to be more painful, drawing other hornets to the victim, and breathing difficulties. Though the venom is very potent, it normally does not kill humans unless caused through an allergic reaction or multiple stings. The top speed of the Asian giant hornet is 25 miles an hour, and their prey of choice is honeybee larvae, which they feed to their young and then have their young eat and digest the honeybee larvae only to eat their young's regurgitated food for energy. But their prey of choice is the honeybee larvae, and they will ravage an entire honeybee hive to get to the larvae. And rather than using their stinger, they'll use their strong manacles to rip apart honeybees. And one hornet can rip apart 40 honeybees a minute.
Okay, for my rebuttal to debater B's opening statement, the while the hornets are much larger than the honeybee and they can rip apart many honeybees very quickly, the Japanese honeybee has a unique characteristic and ability that is unlike any other insect, that they can swarm a hornet and use muscles on their body they start vibrating the muscles and they heat up the hornet to 117 degrees Fahrenheit, in killing the hornet because their body can only survive 115 Fahrenheit. This effect is called bee balling, and they are the only species or insects that can do this.
And my response to that is, even though that is true that they can withstand higher temperatures of 2 degrees higher than what the Asian giant hornet can, and they can kill a hornet that way, it has to be premeditated. They have to sense the hornet in the area to set up for that attack. And if not done fast enough, then the hornet can still send off those signals to get other hornets to the nest. And while that can kill one hornet and save the nest from one hornet, the honeybees wouldn't be a match if other hornets were to arrive.
My rebuttal to that statement is, although that it would take you would think it would take premeditated ability by the bees to respond to the hornet quickly when it attacks the nest. There are bees that are ready for that, for the stay on watch, and their teamwork capabilities is remarkable. Just going off the fact that they are the only insect that does this bee balling effect that can kill an entire hornet in 20 minutes by swarming it and actually cooking it alive. I think that the honeybees, a ton of honeybees, have a much better chance of killing one hornet versus one hornet killing a lot of honeybees, because the bees can just swarm the hornet instead of him just ripping through their nest.
And my final response to that would just be, while more honeybees can kill one hornet within 20 minutes, within those 20 minutes, another hornet could show up, send up off pheromones for other hornets to arrive and ravage the nest. I think it all just depends on where the other hornets are and when the attack happens. If the hornet that's being attacked was able to send off those pheromones to get other hornets to arrive, then, like I said before, they can ravage 40 honeybees a minute. It wouldn't take very many to kill off the entire nest. But I do see your point about them cooking a hornet alive.
For my closing statement about the Japanese honeybee, they are important because they forage more hours a day than the European honeybee, and they pollinize more plants. They also produce a lot more honey, and we should research them because plant pollination is important to us as humans, and so is the production of honey. And they are incredible because of the unique characteristic that they have of bee balling, which is unlike any other form of defense mechanism from any insect.
And for my closing statement, I would say that the Asian giant hornet has a mixed impact on human society. Asian cultures eat the Asian hornet fried and as hornet sashimi. So through that way, it has a positive effect, though I do believe we need to research it more closely, because if more people develop an allergic reaction to the sting, since it is so potent, more lives might be lost. Already there are 30 to 40 people a year in Japan alone being killed by the sting. So I do think it's going to be very interesting and crucial to research them and how their sting and overall existence affects us.
Thank you for watching our debate.